Okay, so we'll go ahead and get started with day 2. So we're going to try out. So we're trying to figure out a couple of different options for lecturing and handling questions with, this is the largest group that we've had. So we're going to try out a couple things. So we're going to try out today using the Zoom Q&A function. So if you have a question, you won't be able to talk, unfortunately, but you can ask it in the Q&A, and we'll so we've got other people handling. So some of the TAs can answer, or any other instructors. And if anyone on like the panel, like the instructors or TAs feel like a question should be answered live, feel free to just jump in or make a comment at any point, really. Okay, so today I'm going to assume everyone can see my screen. Looking at the README for Tuesday, February 2nd. And so we're going to cover Git. I'll go over doing a challenge and the whole process of forking and cloning and all that. And then we'll take a look at some JavaScript fundamentals. Okay, so but before we do that, we'll start the day off with by going over one of the challenges. So we'll look at the 99 bottles challenge, and we have a volunteer. Let's see. Gee, let me go ahead and unmute Ahmed.
Hey.
Yeah. Oh, are you unmuted?
Yes, I should.
Okay. Cool. Yeah. Cool. Okay, I can hear you, so that's good. All right. So so we won't always do something like this, but we'll have Ahmed share his code, and then we can kind of talk about it and walk through your thought process and all that stuff. So I'm going to share the screen again. So let's see if we can find it right here.
Yep.
Okay. So we got the JavaScript solution. Look at the file. Okay, so this is Ahmed's solution for 99 bottles. So Ahmed, can you just tell me about what's going on here at the very top of the file?
With the comment, I learned that whenever you write code, you should always comment at least at the top, explaining what this function is going to do. And then the author and version are my name and then the date. It's just something I picked up while I was in school.
Okay, yeah. So so this is kind of a standard, this would be like a standard industry practice. You don't necessarily have to do that for these challenges, but this is definitely like more professional looking. Kind of describing what the function is. So typically, a file will be restricted to like one class. We haven't talked about classes yet, but maybe one class or function or something like that. So there'll be a description, and then version info, something like that. Or author. So you may find different practices at different companies, and obviously be different standards. So when I was working at Motorola, actually they had us stop writing our names at the beginning of files just for legal liability reasons. So if you get, if Motorola gets sued for whatever reason and your name is in the code, then you can be pulled in to the lawsuit. So I don't think you have to worry about that, Ahmed. But that's just something to be aware of in the professional world. So good. Do you have a doc string at the very beginning? And then can you talk about your function that you've created?
Sure. So the first thing I check is if a user inputted a negative number.
Okay.
And if they have, I say you can't have a negative number of beers, and I exit out.
Okay, so can I ask just why did you do that?
It was part of the additional requirements that you guys put up. Make sure you're able to handle any number inputted, and a negative number is one.
Yeah. So this is a good again in production grade code. You're going to want to handle anything that a user or whatever is using this code. So you're going to want to handle errors and edge cases. So you might imagine, why would anyone put in a negative number into this bottles of beer song? You can't do that, but potentially that could break. So you want to be able to handle errors and edge cases. So that's good. So we're handling, this could obviously be a lot more robust, but this is good, and it shows the basic idea. So we're handling errors and edge cases here, and then you move on. So it looks like you've got kind of 3 chunks.
Yep. So the second chunk is if it's greater than 1. Now I don't have to worry about the plural. So what happens is, it just sings the first sentence of or the first part of the sentence, subtracts 1, sings the second part, and then recursively calls the function again.
Okay, so is this legal in JavaScript? This seems kind of
I have no idea.
wacky.
I learned recursion on Java, and
Okay.
I'm not sure if it's legal or not, but it did work.
So if I copy this and run this in VS Code, am I gonna blow up? Actually, we can just run it in the browser real quick. So I'm gonna open up the developer tools in the browser. So the shortcut is on a Mac is Option Command I, and I can go into the console here and I can actually run this in the browser. So I'm hoping that this isn't gonna blow up my computer.
It's not.
I know, I'm just kidding. So yes, you are allowed to use recursion. So we're not really going to talk about recursion right now, so don't worry about it. Recursion is it's a confusing concept, and it will likely take you a while to grasp if you don't already grasp it. But when you're dealing with recursion, you need to think about 2 things. One is a base. Well, the thing you don't want with recursion is an infinite loop, right? So if you have an infinite loop, your call stack will fill up. We can talk about that later. So basically, your computer will blow up eventually because you can't just keep running stuff forever. It creates more memory and so on. So you have to be able to exit the loop, and that's handled here. So this parameter gets passed in. There's a check. It gets reduced. Eventually, this base case condition is met, and we no longer recurse. So the basic structure of the recursion is you have like an iterating case, kind of like a case where you continue to recurse again, and a case where you stop. So you've handled that. We don't have infinite recursion. That's good. So why did you use recursion here?
Again, one of the additional requirements was don't use loops.
Okay.
So
sure.
Yeah.
So this works. So this works just fine. This is an acceptable solution. Is it? There's a million ways to do this problem, but this is definitely one of them, right? So you can use a loop. You can use recursion. There are actually some languages that don't even have loops. So we're learning JavaScript. We're going to learn Python. So we have loops. But there are languages that don't even have loops at all, and you can still do everything. So anything you can do with a loop, you can do with recursion.
And then the last part is if there's only one left. So I took care of the singular, and then I made sure that if the user actually inputted 0, it would still work by dismissing the 3 ifs and just printing out the last 2 console logs.
Okay, cool. So we're going to go ahead and open, let's see, desktop. I'm going to try to run this. And So I'm going to open VS Code, and I'm going to copy this, and I'll paste it in there. I'll open up the command line terminal with Control tilde. So Control tilde, that's the shortcut. I'll create a file and bottles.js, and I'll paste this in here. Okay, I'll save it, and if I want to run this, I can do node bottles, and then I just press BO and tab, and it auto completed. And I run it, and it looks good. 1 bottle of beer, no more bottles. Okay, so it looks like this works, right? So that's good. It runs in the browser and in Node. So that's nice. So let's ask some questions. So, you know, a lot of the code that we write, we have this problem when we're, you know, when we're first learning something. There's kind of everything's a little bit artificial. But if you know, try to imagine that you're doing this in a company. So you've been assigned this story or task, and you've been told, okay, we need to add some functionality. We need to add this, right? So you write your component, you push up the code, all of the tests run, it passes, it gets integrated into the code base, and now it's part of the code, right? But then you leave your job, or you move on to something else, and some new person gets hired, and then they want to add some functionality. So let's say that your boss comes and tells you, okay, our bottles of beer app is doing really well. We want to expand the market, but so we want to start, you know, marketing to kids, but we can't have beer. So we want to have one app for beer for adults and one for kids where it says soda instead of beer. So how do we handle this?
So I would create a variable.
Okay.
Where, you know, I would say adult song, and then it would be bottles of beer, and then kids song, cans of beer, and and I would replace the that string with the variable.
Okay, so let's try doing that. We'll have we'll copy this, we'll paste this down here, and now we have bottle of soda, and then we have, let's see, we've got sodas and soda and soda. Oh man, there's a lot of changes. And what here? Soda, and let's see, we got soda. So we can keep going, and
there's a lot.
Yeah, there's a lot. And I don't know, you know, maybe you're in a rush, and it's easy to make mistakes. So there's a couple spelling mistakes in here, and it's just, now we have we have a lot of repetition. We have 2 different things that are kind of doing the same thing, right? Only a little bit differently. So is there a way that we can kind of condense these 2 functions into one more general purpose function that's maybe a little easier to maintain and use?
Having more than one input.
Okay. So, right. So you're talking about the parameter here, right?
Yes, correct.
Okay, great. So yeah, so we could add a parameter. So let's try doing that, and then we'll have drink. And then everywhere we have beers, can we replace it with
the variable drink?
Okay, and how would we do that? So there's a couple ways that we could go about doing this.
You can do it the way that I did it below, where you end the string and then do plus the variable.
Okay, so we could do something like number of, let's say, number of, and then plus, and then quotes, and then
no quotes.
Oh, right, sorry, yes. Actually, probably want to have space then, number of space, and then drink, and then it's got to be plural, right?
Yes.
So plus, and then quotes, and we need to not have a space there, right? Okay. So that looks like it'll work. So we'll just try it out real quick. We only have the first line written, but and then we'll have. And we'll change our function name, bottles of beer, to bottles of drink. Okay, so let's try, oh, we gotta change this here. Oh yeah, the recursive function. Okay, so bottles of beer, beer, beer. Do we get, did that not work?
You only change it for the less than 0. You would need to change it for the greater than 1 and the 1.
Oh, right. Oh, geez,
Yeah.
sorry. Yes. So that condition is met. So, but if we do -1, actually, we'll try that. Okay, so that does work. So yeah, so I don't want to go through and change everything. That's going to take too much time, but this is the idea. So one option for putting together strings is to do something like this, where you just concatenate in chunks. You can also use string formatting. So you could do, I'll just rewrite this line right here. So we have template literals, and we use not quotes, so we use a backtick. So we'll have the backtick, and then we can just keep, it's a little bit easier to see, spacing and formatting, right? So we have number of, and then we use the $sign in the brackets. We insert our variable, and then we can add an S right there. So that should print the same thing. Right, so that works too. The choice is yours, but I think some might argue that this is a little bit easier to read and maintain.
The bottom is cleaner.
But either works. So and you'll see both in code bases. So yeah, so this is good and it works. But I just want to make some of these points where we think about writing the code and just it's kind of an avoid, especially in the beginning. But the reality is you should be like starting to think about other people being able to use and modify your code. Because code, it's never just written once and then it stays there forever. It's constantly being iterated over or changed or tweaked. So you want to make sure that things are maintainable. So, and a lot of what makes it maintainable will be context dependent. So for example, when you first wrote this function, you didn't imagine that anyone would ever tell you that it would need to be either bottles of beer or bottles of soda, but that's just something to think about. Okay, so very good. Thank you for volunteering, Ahmed. Appreciate it.
Thank you for the feedback.
All right, cool. So went over 99 balls a little bit. So after the lecture, we'll break up into the smaller groups and we can go over other stuff if people have questions. But for now, we're going to go ahead and move on to Git. Are there any, if I can ask the panelists, are there any questions about that so far?
Nope.
Okay. All right, so let's talk about Git. So Git is a version control system, which, so let's take a step back real quick and we'll go ahead and ls rm. So if I want to remove a file, rm bottles.js. Okay, so I'm gonna start a new project. I open up my text editor. Let's say that I'm trying to write a term paper, right? So, maybe something longer like a thesis where I write and I have one version. So here's my thesis.txt, and this is very long. So I save this file, and then I come back and I say, you know what? I just found out some new information. So I'm going to go ahead and I'm going to change this. So I'm going to have a new file. This will be my thesis 2.txt, and so I want to keep the original just in case I need to go back to it, right? But I'm going to change this. Save this, and okay, that's great. So I got my drafts done, and now I'm ready to turn it in, right? So I've got my file, final.txt, and I'll just go ahead and copy this. And save it. Okay, so that's good. But then, maybe, I have someone proofread it and they find some mistakes. So I make my thesis final 2, and you can, this just goes on and on and on. And by the time you're actually submitting this thing, you've got 50 different versions. And it's just, a pain to deal with. So Git solves this problem. And it solves it because it's a version control system. So I write a piece of code, and software engineering things are constantly being changed and updated and everything. So everyone's working on this. So we have a piece of code, and I make changes, and then the final version, or the current final version, is what would be called the master. So we have branches we've seen, right? That would be the master branch. So Git is a version control system, tracks file changes. There's a history that you can access that will tell you who's done what. You can back up and restore work. So it's also just lighter weight. So rather than saving 50 different full versions of a file, you have basically one version and then a bunch of snapshots, which are only the differences between from one version to the next. So it's also lighter weight. Okay, so we'll go ahead and look at this Git visualization. So we have this master branch, which is kind of like you can think of as the current final version. So the final, whatever the final version is, can constantly be changing, but this is the current final version at any one time. And the workflow is typically going to be, I have my code. So I've written my function and it seems to be working. I'm satisfied with it. But now I want to add a feature. So if we think about Ahmed's 99 bottles code, we have the 99 bottles, right? So that's master now, and everything's done, and we move on to other things. But then at some point we come back. Yeah. So master or main. I think they've recently officially changed it to main. So it could be master or main. It's whatever the name is. It's that's what it is. So we have this function, right? So but then your boss says, hey, we need to make a version for kids, right? So we need this bottles of beer to be bottles of beer or bottles of soda. So your job is to convert what you have to add a feature or to change the code base. And in order to do that, what you do is you take whatever is in master. So you take the current final version and you basically make a little copy of it, and you take it off to the side. So it's out of the main branch. So if anyone else is accessing the current final version, they're still going to get this original version. So you make a copy of the current final version and you start working. Once you're done, you're going to want to push it back into the master branch because you want the current final version to be what you've done, right? You've added this new feature, and now the current version of this function is beer or soda. But meanwhile, maybe someone else has done, for example, another feature. So it's beer or soda, and some additional error handling, right? So this person's working on more robust error handling, and you're working on beer or soda. But you can both work on these things simultaneously. So the tricky part will be when and how you merge everything back into master. So we can talk about that. There are some tricks, but it's not so important. The basic idea is that there's a workflow, which is I write some code, I initialize a Git repository, I make it a Git repository. It's on master or main by default. I want to make some changes. So I create a branch, I add a feature, I do whatever. Once I'm happy with that and it's all working, I want to merge it back into master so that master will now include my most recent changes. And then I can keep working on, if I want to add another feature, then I create another branch, right? So the workflow is you have the baseline, the master current final version. When you want to add a feature, you create a branch, and then when you're done, you merge it back into the branch, and you can repeat that process over and over again. You can have multiple people working on the same code base. So it's really good for the way code actually gets written, which is collectively and over and over again. So Git is structured to, by the way, Git is kind of a whole like witch's brew, I guess. So you'll have Git gurus. You'll probably have at least one Git guru wherever you work. That might be you, might not be you. But whether you're the Git guru or not, there's some basics that everyone has to know, and that's what we're basically gonna be covering. So the structure of Git is you have a working directory, which is just wherever you are in your file system. Then you have a staging area, which is basically this intermediary zone where anytime you make changes, you kind of let Git know about them. You prepare them for adding it to the final repository. So this is what Git Add does. It takes stuff from the current working directory into the staging area, and once everything has been staged, then you commit it. So you move it into the Git repository, and it becomes it gets marked. It gets identified with something called a SHA. So it's a unique identifier, which we can take a look at in a sec. And once it's committed, then you have access to it. So it's now a part of the Git repo, and you can go back and look at it if you want. So you don't have to do, my file 1, my file 2, my file 3. You just have my file, and then you can use Git to go back and look at previous commits. Okay, so here are the basic commands that you'll be using on a daily basis. Well, maybe not Git init, because we'll be pulling down repos that are already Git repos, but Git init is what you do if you want to start this process on your local machine. By the way, I should mention that there's a difference between, I would have asked the class. This is a little bit weird since I can't ask people questions, but there's a difference between Git and GitHub. So Git is this, version management system that exists on your local machine. And GitHub is basically just cloud storage for whatever you're working on. So when we talk about Git, we're talking about whatever's happening on your local machine. We obviously use GitHub, but that's that's in some ways that's a separate process. So what's happening on your local machine is you get init, you can check out to a new branch, which basically means create. So git checkout -b, and then whatever your branch name is, that will create a new branch and move you over to it. So if I'm on master and I'm working on bottles of beer, my boss tells me, hey, we need bottles of soda. I do git checkout -b bottles of soda. And then I have a new copy of whatever the current version of master was, but I'm operating in this separate branch. So I'm not gonna, anything I do isn't gonna mess up what's on master. So I work out, I'm on git checkout -b bottles of soda. So I'm on branch bottles of soda right now. I can do git status just to check and see everything. And we'll see this in action in a second. And then git add, this will move everything to the staging area. You can do git add dot, which will add all of the contents of your current directory, or you can individually choose files and so on. Then once you've added it to the staging area, you do commit. And this -m flag just allows you to write a message. So again, software development is a collective exercise typically. So you want to write messages that allow someone else who comes and looks at what you're doing a year later to have as clear an idea as possible as to what you were doing. And then you can use checkout. So checkout and then a branch. There's also some other things. We'll look at git checkout in a second. And then merge. So you can check out. So check out means move between branches. So you create a branch up here, you do some commits or whatever, and then I want to merge it back into master. So I have to check out or go back to master. And then I can do merge the new feature. And then the code that I wrote on my separate branch will now be part of master. So Git is very, it's not the most intuitive thing, but we'll do it over and over again. Like many of these things, you don't need to try to memorize everything right off the bat. You'll just do it so much that it'll become a part of how you work. Okay, so let's just look at an example real quick. Okay, so we have, I'll just delete these. All right, so ls, I have my thesis here. If I do ls-la, I want to see all of the hidden files. Okay, so the first thing I do if I want to make this a Git repository, right? So I've started my essay, and now I'm thinking I'm going to go back. Yeah.
Do you mind zooming in on your terminal?
Oh, yes.
Yep.
Sorry. Okay, is that better?
Perfect. Thank you.
Okay. So so now I'm here. I've started writing my paper. Maybe we should make this code to make it more relevant. Let's just do. Okay, and now. Okay, so I've got my code here, but I know I'm going to end up coming back to this, revisiting it over and over again. So I want to create a Git repository just so I can manage different versions. So if I want to take this and make it a Git repository, it's pretty easy. You just do git init. So git init, I get some feedback. I initialize empty Git repository and so on. So you can see that it's added a file, right? So if I do ls, I can't see it. Where is the file? Well, it starts with a dot. So it means it's a hidden file. So I can use the -a flag. And I can see that now I have a .git file. So I can cd into that. In ls, I can see we have all these things. I have head, Head is basically a pointer to where you currently are. So there's all kinds of stuff. You'll never need to go in here, but just so you know, this is just, it's a file and it's got some stuff in it. It's not magic, although it is kind of a pain. Okay, so we've created our repository, and now what I want to do is let's just do Git status to see what's going on. Git status. Okay, so I'm on the master branch. I don't have any commits yet, which is right. I haven't committed anything, and I have untracked files. So Git knows that I have a file, but that file doesn't exist in the staging area. So if I want to add this file to the staging area, I can do Git Add, and then I can either do dot to add every file that's in this current directory. We only have one, so it wouldn't make any difference, or I can add specifically my code.js. So I'll just do this. ls, okay, everything looks the same, but if we do Git status, you can see we have some reassuring green here. Maybe we've done something right. So now Git knows about that the file in my working directory matches what's in the staging area. But that's not enough, right? So if I actually want Git to remember where I am, like create a save point for me in this file, then I'm going to need to commit it. So Git commit, and we'll add a message. And typically, for the initial commit, you can just do initial or something like that. Usually you want to have a more informative message, which we'll see maybe in a sec. So Git commit, okay. Couple things have happened. Now my terminal, my bash profile knows that I'm on master branch. And if I do Git status, on branch master, nothing to commit, working tree. So that means that everything that's in my working directory matches what's in the Git repository. So I can now, rest assured that if I make changes, I can come back to this if I need to. So let's say we've got our commit. So now we've got our Git repo really working, but I want to add a new feature. So the workflow for adding a new feature is creating a new branch, working on the feature, and then merging it back into master. So we're going to create a new branch. Yeah, okay. So we'll create a new branch. So Git, the command for that is checkout, and the flag will create this branch. So B, and then we'll add a goodbye. So the feature is adding goodbye. Checkout. Okay, switch goodbye. I'm going to add my feature. Okay, I save it. I'll do Git status. You can see that I've made changes in my working directory, and that those changes aren't reflected. So Git doesn't know about them in the staging area. So I can add those to the staging area. So Git add, and I'll just do dot. So that will be all the files. I can do Git status again. I'll press the up arrow to rerun, go through my history. I'll rerun this command, Git status. Okay, now everything's good. I'm on branch goodbye. Notice I'm on goodbye instead of master. So I'm on goodbye, and I'm going to commit to this branch. So Git commit -m adds. So commit messages, and things may be a little loose, but I think the general idea is that you want to make it descriptive, so you're telling other people who see your code what you're doing. So using the present tense is kind of the standard. So adds a goodbye, something like that. Okay, and now if I do Git status, on branch goodbye, nothing. So everything's good. My my changes are committed. So now at this point, I would merge over to master. But first, I'm gonna check out to master just to see what's going on with master. So watch what's going on up here when I do that. So I'll change Git checkout master, and that other line just disappeared, right? Because master branch doesn't know anything about what I've been doing on goodbye branch. So I'm gonna go back to goodbye, Git checkout goodbye, and now it shows back up because my changes are only on the goodbye branch. So if I want to merge this, I'm going to check out back. So I'll go to command history with the up arrow, check out back to master, and I'll do merge. I want to merge these branches. So I want to merge goodbye into master. So from master, I'm going to do git merge goodbye. And now we have, so I'm on master, and now these changes exist. So my new feature is now a part of the code base. So if I want to check out what I've been doing, I can do I'll do Git status first. Okay, everything's good. I do Git log. So Git log. And I can see a history of the commits that I've made. So this is my initial commit. And this big long thing is it's a hash. So it uses SHA. It's one particular hash function, SHA-1, I think. It basically, what it does is it takes all of the metadata and what's in the file and generates a random sequence that should be unique, right? So you want to have hashes that are unique, so that there are no collisions, there are no like doubles. So I'm gonna just, so we can see that these hashes are two totally different numbers, right? It's not like just a couple things changed, right? So let's go ahead and we'll just add a single space, and we'll save it, and we'll commit again, and then we'll look at the commit hash. So git add dot git commit adds a very important space. Okay, and if you do git log, we now have a new hash, and notice the difference between this one and this one was just a single space, but these are totally different numbers. Because the hash function, that's just how it works for all kinds of reasons. So that's it. And if I want to like look at a version, we're not going to talk about going back and changing. So some of the stuff gets more complicated, but we'll just see that we can actually go back. So I can go back and take a look at least at this first commit. So git checkout. So we use checkout to move between branches. We can also use checkout to move between commits. So instead of giving it a branch name, I'm going to give it this commit hash. So we get all kinds of things. So we're in a detached head state, so you can see that I'm now looking at my code as it was for the first commit. We don't have to worry about this, but it is possible to revert changes, but it's a little bit of a pain. So we're not going to look at that right now, but that's the basics of how Git works. So Git. Okay, so now we're back on master, and this is now our final version. So again, just to review the basic workflow, take a look at this slide again. So we're on master. We've done git init, right? We've done git init. So now our folder is a Git repository. We can add a new feature. We create a branch. We work on the feature. Then we merge it back in to master. And then we can just continue this process over and over and over again. The basic structure is you have a working directory, a staging area, So you add something in the staging area with Git Add, and then you add it to the repo, your local Git repository with Git commit.
Hey, Chad, I just want to add something.
Yes, sure.
When you're cloning these challenges from GitHub, they already have a Git repository initialized, so you don't have to reinitialize the Git repository. So you can just commit and add to the existing Git repository. Just a reminder.
Right. Thank you. Yeah. So things are slightly complicated by using GitHub. So what I've just talked about is basically Git on your local machine only. So we obviously interact with GitHub, which adds some complications like, forking and so on. Okay, so talked a little bit about Git. I think okay, well, let's go ahead and look at GitHub while we're here. So we have the 99 bottles challenge. So November Platoon, 99 bottles. This is already forked for me. So let me go back here. Okay. All right, so I'm here. Let me go ahead and delete this from my repository. Actually, that's not my repository. Okay, so I'm sorry. Okay, so I'm here on this challenge that we're gonna, these should have already done, right? So we can see that November Platoon, this is November Platoon's version of 99 bottles. I want to create my own, basically clone the whole repo. Essentially, that's what forking does. So I'll fork it. So I'll go ahead and fork it to my account. So this is copying over. So now, where before it was November Platoon /99 bottles, now it's my own personal account /99 bottles. So I have my own, independent copy of the entire repo. So what I get to do is I'll copy this and I'll clone it down. So let me open up this. I'll delete that. And I'll do, let's see. Okay, so I'll clone the repo. So I just forked it. I'm going to clone it. So Git Clone. I'll paste in the URL. And again, this is the URL from my from the version that I forked, not November Platoon's 99 bottles. So I have it here. So I can see the files. So now I have a file. So I'll add code. I save it. Now if I do Git Status, whoops, I got a CD into it. Okay, Git Status. Okay, so now we see the same thing. So again, as Tom mentioned, because we're using a repo that's already, a Git repo that's already been created for us, we don't have to, and probably can't or shouldn't use Git init. So we've cloned it down, we've forked it, we've cloned it down from our fork. We're looking at it locally. We made some changes locally. So we want to now add it. So we need to move our changes from our current working directory into the staging area. So Git Add, just like we were doing before. And we can do Git Status, the up arrow to move through my history. And Git Commit. Something like that. So yeah, I didn't talk about creating branches, but we should typically what you want to do is create a branch. So we can do, anyway, we'll just leave it like this for now. We can talk about branches later. Okay, so now I have git commits, so on and so on. So now what I'm going to do, so this is different than just running GitHub locally, which I talked about earlier. So now we're going to take this Git repo that we have, and we're going to basically, we want to store it on the cloud. So we want to push it up to GitHub, which is just one of a number of, you know, that kind of, there's whatever they can't, Bitbucket is another one. There's a few competitors to GitHub that all do the same thing. Okay, so in order to push my local Git repository up into my GitHub Git repository, I do git push origin, and then whatever branch that you're working on. In this case, it was master, but you know, in the future, it'll be whatever branch you added your feature to. So master. Okay, so it looks like everything went through fine. So if I go here, so I'm on my forked copy. If I refresh this, I can see that, so my commit is now, this has been updated. So at this point, I've gone to Code Platoon's 99 bottles. I've forked it over to my GitHub site, my GitHub account. So I have my own personal copy of the entire repo. I clone it down to my local machine. I work on stuff. I make changes. I commit it on my local machine. Then I want what's here on GitHub to reflect what's on my local machine. So I push it up. This updates what's on GitHub. And then what I want to do is this, again, this is a little bit artificial, but in a realistic scenario, if you were like contributing to an open source project, this is how you would do it. So you'll make a pull request. You say, hey, GitHub's 99 bottles repo, I made some changes and I think you're gonna want to include this. So I'll make a pull request, and you can just do new pull request. And something like this will probably show up. If not, you can configure this manually. So we want to push whatever my local, so Chad Mowbray 99 bottles, so my master branch in this case, so it could be a local feature branch that you have. We want to push that into November Platoon's 99 bottles master branch. So that's what we're trying to do here. So I click create pull request, you can add a comment and create pull request. Okay, and that's all you need to do. And then we're not going to merge the pull request because we want to keep that repo without solutions. That's the whole point. But once you do that, you're done. And if you ever want to update, so I just have solution. If you ever want to update, it's easy. You just make changes. You can go through the process again, right? Add some more code here, do git commit and so on. Push it up, and the changes will be there. So you can just repeat that cycle again. Okay, so that's if this is all confusing, which it likely is, don't worry about it. We're gonna see this happen over and over again. You're gonna do this over and over again. All right, so next thing we're gonna cover, so we've covered kind of Git on local machine, GitHub as we use it for submitting the challenges. We talked about pair programming yesterday. I don't think I need to go over that again. So we'll get some more experience doing that. But obviously the basic structure is driver and passenger. So driver is actually doing the code. Sorry, not passenger, but navigator, driver and navigator. The navigator has maybe higher level stuff, maybe is looking up stuff, thinking about the higher levels of abstraction. So that's the kind of dynamic that you want to get when you do pair programming. All right, so let's talk about JavaScript fundamentals. Okay. So JavaScript was created kind of in a rush by Brandon Eich. So if you look at different languages, you can see that first off, it is possible to create your own language. It's not impossible. I mean, it's fairly easy to create a very, very simple language, and difficult to create a robust, full language that people will actually use. But so Brandon and I created this one. There are some quirks that JavaScript has as a result, but it's just increasingly growing in popularity, and it's likely to maintain its popularity. Okay. So JavaScript has data types. You may have heard that everything in JavaScript is an object, which is kind of true. We can look at that in some detail in a second. But we have strings. So this should all be basically review for people. So you have strings. Strings are enclosed in quotes. You have single or double quotes. You can use backticks. You don't have to interpolate. If you can just use backticks as quotes if you want. So this should all be fairly clear. We saw this when we were looking at the 99 bottles of beer challenge. We have numbers. So basically, there's just one kind of number. So you don't have to. So JavaScript is dynamically typed. So you don't have to assign. You don't have to assign a type to a variable, as you do in many other languages. We have Booleans, which are just true or false. There's also truthy and falsy values. So things that evaluate to true, like 0 is false, and so on. And undefined. So undefined is basically the default value. So if I run a JavaScript file, any variable that isn't assigned a value explicitly will just be undefined. It's kind of like a temporary value. Null is a deliberate indication that this value has no value. Okay, so we have these kind of you can think of as primitive types. There are actually some more data types. There's big int, which is a newly introduced one. There's symbol, but we're not going to worry about that. Let me go ahead and okay, so I'm gonna all right. So if I want to find the type of something, I can do. Actually, we'll go ahead and do some of this in the interactive terminal here. So node, and we'll do type of. So that's a string. So we'll use type of, then space, and that'll tell us what type of something. So type of 7 is a number. Type of let's see what else. String numbers true. So type of whatever true, that's a Boolean. So all this stuff is pretty that's what we would expect, right? What else do we have? Booleans, numbers, undefined. Okay, right. So type of undefined is undefined. Okay. Type of null is object. Okay, we're getting some. It's a little weird now. Type of null is object. What about the type of an object? It's also an object. What about an array? Also object. Okay, so this is a little bit weird. So JavaScript has some introspection functionality. So type of is one of them. There's some more stuff that we can look at. But so we can see we have these primitive types, basically. So strings, numbers, Booleans. and then we have, let's say, you can think of it as there's objects or things that are passed by value and things that are passed by reference. So we'll look real quickly at passing by value versus passing by reference. So if we do let x equal 4, let y equal 4. Sorry, let me do that. We would expect this to be x exit so this is true, right? So the triple equals is actually going to check for the type. So it's the value, like, so if you just do 2 equals, then JavaScript could coerce values, so you can get some different results. This is the strict equality operator, so that's true. What if we do something like this? And okay, so that's also true. What if I do something like this? So these are not equal, even though you might think we can do right. So these are primitive values, which basically means that there's only this is the actual value. So x really is 4, y really is 4. But when we do these other things that are type of objects, like objects and arrays and functions, this gets evaluated differently. So it's actually not passed by value, but it's passed by reference. So this variable, my object 1, it doesn't hold the actual object itself. It holds a reference to the object. And this operator, the triple equals, is going to compare the reference. So it's going to look at the is this identical? Is it the same reference, and so on? Yeah. So that's one difference between these two basic classes of primitive types and objects that are handled by reference. Let's see. So we've got variables. So let's talk about variables for a sec. So we have these 3 different ways to declare variables in JavaScript. So we have var, let, and const. So var was the original only way to do it in JavaScript. Let and const were introduced in ES6, I think. So just to show you some of the differences. So it may not seem like it's a big deal, but there are some tricks. So var x equals 2 and var x equals 3. Okay, so I've declared a variable here, x, and I've assigned it to a value, and then I've redeclared the same variable and assigned it to a value. So what if I change this to let? I get an error. So the syntax error, identifier X has already been declared. So var is basically very loose. So one thing is that you can redeclare the same variable. So you can imagine that that could create some problems down the road. So you have a large code base, lots of people working on things. So being able to redeclare a variable could cause some issues. There's also scoping issues. So var has two scopes. So scope is basically where you can access the value in your code. So there's global scope, which is anywhere in the file, like anywhere that you're working, you can access the value, which is usually not a good idea. And you have function scope. So I can declare a variable inside of a function. So var, so I'll do function, and then something like that. And then if I try to oh, sorry, okay, I can't do that. I thought that I could only do that with if statements. Let's see. Oh, what am I doing? X. Okay. Sorry about that. So I have a function and I've declared this variable inside the function, but I can't access it outside. So this is outside of the scope. This is in the global scope. So I can't access whatever variable I've declared in this function. I can't get at it outside here. Okay, so var has two scopes, global and function. Let has introduced, so let and const use, there's an additional scope. So there's anything inside of curly brackets. So if an if clause, a function, even like a try catch block or something like that. So anything that happens inside of curly brackets will have its own scope. So we can try that here. So if true, so we'll do var first. Var x equals 9. Comment this out. So here I can access, right? So when I had var, when I declared this in a function scope, I couldn't access it out here in the global scope. But here, if I have an if clause, I still can. So I've declared this variable inside of an if clause, but as far as JavaScript is concerned, I can still access it. So this is still the same scope. Now, if I do let here, and I try to run this, X is not defined, right? So this X in the global scope doesn't know anything about this. So this variable is scoped within these two curly brackets. So that's another difference between let and var. So let allows you to scope variables in more places. The other difference, so we talked about var and let a little bit. Const is also one. So const is basically if I don't want to reassign a variable. So if I'm sure that this isn't going to change, const x equals 0, x equals 9. Okay, so I get an error, type error assignment to constant variable. So I tried to assign a value to a constant variable. I can't do that. If this were let, or var, it would be fine. But with const, you can't do that. Now, we talked about passing by value versus passing by reference. So here, number is a primitive type. So this x contains the actual value 0. But if instead of, let's get rid of this, we'll do my object. Let's do an array. My array equals, we have an array and 1, 2, 3. And if so the question is, which I would ask if I could interact with you guys, would be, is it possible to change this? So I could try doing something like, I don't know, new r equal my r. Okay, so that's fine. But what if I want to, let's see, my r equals 1, 2, 3, 4. Again, we have this same issue, right? So the same issue we had with this primitive type number we have with an array, which is handled with reference. So I can't reassign, can't explicitly reassign to this variable once I've declared it. However, because this is just a reference, we can actually kind of get around this. So we can still change, you can still change this array. So if I do my r dot push 4, so I'm going to add 4 onto the end of my r. Now we can see that my r has actually been changed. So even though this is, I initialize this as a constant because, this is an array which inherits from object, the prototype is object, I can still change it indirectly. So the reference doesn't change, but the contents have changed. That's just something to be aware of. So that's, so speaking of introspection, I just want to talk, so we're not going to get into classes and stuff like that right now, but I just want to show you that you can do some introspection of objects with JavaScript. So we'll go back. Okay, so let's see. So I'll create a variable. So let x equal 0. And if I want to see what prototype x is, so x dot proto, it's number, okay. So prototype is basically, you can think of, so I have this thing that I created, right, which is this number 0, but it's kind of wrapped, JavaScript basically wraps it in an object that allows, and that object has a property basically called proto. And proto gives me a link into the next stage up in the hierarchy. So there's a bunch of stuff in this second layer. So if I look for something in the first layer and it doesn't find it, it will use this prototype link to go up the chain so it can look for stuff there. If it doesn't find it there, it will see, is there a prototype link to something even higher? If yes, it'll jump over here and look for things in there. Otherwise, it'll say, return an error and say, I couldn't find what you're looking for. So, so we can go up in the prototype chain again. Okay, so I created this number. This number is basically like a number object. Gets wrapped in this number object. This number object, its prototype, it's basically created from an object. So an object, so we hear everything in JavaScript is an object, right? So let's see if we can go up again. And we get to null. So let's see if we can go up even higher. we cannot. So null is actually at the very top of the, top or bottom, depending on how we want to look at it. So there's null at the very top. That's like the root node of JavaScript. And then there's object. If I want to go down to this humble 0 that I created, it goes null, then object, then number, then my specific value. So you can do stuff. And also I just want to point out, so you can use proto to kind of play around with where your specific thing is on the JavaScript hierarchy. You can also do, let's see, it's so on the object that's get own property names, and I can pass in X, and it'll return an array of. So this doesn't have any in this case, but I can do X. So if you want to know how, for example, you can create an array and then have access to. Actually, I'm going to do that first. So just an easier example. So let y equal an array. Okay, so my R, I've created an array. If I look up the prototype hierarchy, it's going to be array and then object and then null. So I could do object. So if I want to know, like, okay, so if I create an array, I can access the length immediately, right? So I can do something like my r dot length, and it's 0. I get a value. So how does, I didn't create, first off, I didn't create an object. So why am I able to access something on this array with a dot property notation? And I didn't create a length property. So how does this array that I created have a length property? So we can see we have y, whoops, my r. Sorry. So we can see that JavaScript gives a length property to this object that I created. Okay, what about things like popping and pushing and all this other? So we use push on this array. Again, I didn't create this method on the array that I made. So dot. And here we have my r dot proto. So let me just paste that in. You can see what that is. So this is like just, the array, and we can have all these properties. So length, copy, find index, push, unshift, split. Also all of the array methods that, I'm sure you've come to know and love, you can see here by accessing. So again, I created my little old instance of an array, and that inherits through this prototype chain a whole bunch of other stuff that's built into JavaScript. So that's how you can access all this built-in functionality. Because if it can't find what it's looking for in my specific instance, it'll go up the chain until it either finds something or gets to null. Okay. And then console log. There's also a whole bunch of other, like there's console.error. May not do anything in that. So if let me go to the browser real quick. So instead of so if I did console.log, I just get, this boring old hi. But if I do console error, I get this very exciting, scary message that's in red. So there's a whole bunch of other built-in kind of methods which may or may not be useful to you at any given time. But you can check that stuff out. Arithmetic operators, I'm not going to go over this. The modulus operator is kind of the weird one. It's good for a few different things. Commonly something like finding out if a number is odd or even. You can check the remainder. And we have these comparison operators. We talked a little about the triple equal, so that'll check, basically won't do any type conversion, but you have to watch out for things that are created by reference, things that refer to references, so objects, arrays, and so on. If you want to compare if an object is equal, i.e. has all the same key value pairs, you'll have to do something else. There are a couple workarounds that you can use, but you can't use the triple equals operator. We have logical and or. So I just want to show you this real quick. So there are cases where you might want to declare a variable and then have it equal either one thing or another, depending on some other thing. So you can basically create a variable and then conditionally give it a value depending on what's going on. So let my var equal, and I will do true and true. You run the file, and that is true. Okay, so true and true. What about true and false? That is false. What about false and true? Okay, that's false. But so there's something called, the way JavaScript evaluates conditionals, it's called short circuit evaluation, I think. But so there's no way, we don't have any visibility into here. So I just want to create a function real quick that illustrates the short circuiting. So function, I'm going to write a function that's just going to console log that was called. And then we'll return true. And then I'll do the same thing with false. Okay. Now we didn't talk about this explicitly, but if we do go back in here, so let's do so type of function is function, but again, if I keep going up in the hierarchy with proto, I'll see that it's an object. So that means, so one of the properties of JavaScript, most people think it's a good property, is that functions are what they're called, like first class things, first class objects, but they're actually objects. So I can take a function and I can assign it to a variable just like any other value. I can move it around. I can pass it as a parameter to other functions. And JavaScript will kind of treat it like a variable. So what I can do here, instead of just having false and false, is I can call, for example, return true and return true. So if I run this, I can see that, let me move this down. I can see that true got called, the function got called twice, so it ran twice, and then this got assigned true. So it evaluated this to be true. Now, if I do return false, true is called, right? So true gets called, and this is an and operator. So this is true, so it moves on to the next term, and it runs this. So this gets called, false called, but it returns false. So the result of true and false is false. So my var is false, but these both got called. So the interesting case is false and return true, but we'll see that it doesn't really matter what we put there. So false is called and false. And we could even do something like, I don't know if we could do it here exactly. Something like that. So this is just a bunch of nonsense, but it doesn't even get evaluated, right? So the error doesn't show up. Okay, okay, that's fine. We can do that. So if we wanted to actually assign a value to my var that wasn't just a Boolean, we could add a ternary operator. So we can actually combine stuff like this. Not that this is like a common case, but just to show you. So we can do something like whatever the result of this is. So we're going to test this. So this is going to return a single value, right? This is going to return false. This is going to return true. And this combined is going to return false. So whatever this is, if it's true, it's going to do otherwise, use a colon. And we can run this. It was false. So my var has now been assigned to this value. It was false. So we evaluated some, conditionals here, and then this is put into this basically spits out a single term, which can get evaluated as being either true or false. And then if it's true, the value is assigned to this. And if it's false, it's assigned to this. All right, and then for functions, talked about them a little bit. There are 3 different ways to write functions. It's basically all the same, especially for our purposes now, but there are some minor differences. So if you declare a function here with this function keyword, JavaScript will do what's called hoisting. So essentially it makes it available. You can access it you can call it before it appears in the code. Here you can also assign, you also assign functions to names and so on, like a normal variable, so you can pass it around. Here we have arrow functions. So the syntax is slightly different. So instead of declaring function, we just have parentheses and then an arrow, and then this is whatever. So there are a few other like syntactical variations that we can talk about later, but it does the same thing. There's some minor differences with how it handles this, which we're not going to worry about right now. But for now, you can think of all of these as being equivalent. And we talked about conditionals, the ternary operator, and everything else. So I think that, so loops, I'm not sure I need to really go over loops. So, I mean, there's a number of ways of doing this. So the basic construct is the for loop, which you can really use for anything. There's a more specialized version for objects, or you can use it on arrays as well, but this key will be the index. And then there are we'll learn about later, some more advanced things you can do, higher order functions like map. So especially when you're dealing with arrays, using for loops, it works fine, but there are more specialized tools that we'll look at later. And I think that's about it. So this should have been, I mean, what's contained in here should be mostly review. And then I talked about a couple edge cases and some introspection tools that you can use for JavaScript. So I'm going to stop sharing now. Do we have any issues or questions? I think I'm.
Nope, we can stop recording.
Okay.